I'm a bit slow today. I don't have my mouse and my second screen, and it's a bit hard to move around. Authentication. Let's say authentication, although it's also authorization. Okay, so let me share, and I'll show you what we will be trying to do. And do I have this open here? No. Okay, we will show. We will discuss an easy way to do the basic authentication and authorization processes, like a login and giving access to some hidden information to the user. There are many ways to do that, and GWT, this JSON Web Tokens, it's one of them. So we will be using in this method that I will show you today, we will be using these JSON Web Tokens to do authentication. But there are others. You can use cookies. You can use sessions through cookies as well. You can use OAuth authentication. So there are different levels, and the more complex, it's also more secure. But for our purposes and our apps, we can do something simple like this with a JSON Web Token, and we will see what this JSON Web Token is. So let me see, can I make this like a presentation mode? Or if I open it, this maybe better. I would like to show it as a presentation, but I don't know if I can do it here. No, because present now. Okay. So we will discuss two different things today. One is authentication and the other one is authorization. Any idea what is the difference between the two, or have you heard the terms before?
One is authentication is proving that the person is who they are, and then authorization is what access that they can have.
Yes, nice. Exactly. So authentication is proving that you are who you say you are. And like when we do a login and I say I'm Anna, and I have to prove it by sending a password, and the server checks that the password matches. So that also says, okay, yes, you are Anna. And authorization is once you are logged in to know to which pages you have access, because even if I have a login and a password, that doesn't mean I can do anything on the page. So I can check all the pages. And so there are some pages that are for specific users. If you are an admin, depends on what kind of control you of access grant you have. So authorization is to which places you have access to with your user, and authentication is proving who you say you are, that you are that person. So the two of them are different, and sometimes it's easy to confuse, and we try to say one thing and we say the other term, but it's good to, at least at the beginning, have them clear. We will check mostly authentication today. Authorization can be done also with what we will see, but I don't think we'll have time for doing both things today. So we'll see what they are, or why do we need them, and types of users, anonymous versus authenticated. So when a user is anonymous, can do something. When it's authenticated, logged in, can do something else. So the authorization. So we will not have really, the slides are not that important. The important thing is the demo. I'll show you what we'll try to do and how we build this on the server and how we build this on the client. So again, the two of them have to talk to each other. the server has to connect to a database where the user information is stored and do the checks there and respond if you are authorized, if you are authenticated to the client. And then the client, depends on the response that it gets, can show one view or the other. So the workflow that we will try to do is that the client logs in with a username and a password. The registration process, we will not show here. I mean, we will do it through the Postman, but there is no front-end view for the registration. It wouldn't be that hard, but just to simplify the demo. And so we suppose that we have a user that it was already registered and it's on our database. And so the workflow that we will see is that we have a login, the client logins with a username and password, and on success, the server creates a token and returns it. So we will be discussing tokens, and we use this JSON web token. I don't know if it's called JOT or something like this in shorter. So that's the server creates a token that sends back to the user, so to the browser, and the client has to store this token for later use. And the client stores this token in what it's called local storage. So in your browser, there is a storage that you can keep things. And one of these things is the token, so that every time you refresh the page, you don't have to log in again. It's somewhere stored, and even if you refresh, the token remains there until it expires, because they can also have expiration date. And so you don't have to log in every time that you refresh or you move to something else. And then at the second point, at the second step, the client requests some protected resource. And when you request the resource, the client sends the token together with the request. So the same as we were doing fetch to fetch some data, now we will do fetch, but we will be sending together also in the authentication part, in the header, the token, so that the server can use the token to verify that we are logged in and we are this concrete user. And then if it's true, return the protected resource. So here is how we will be doing it. The client first sends the login part, a post method. It sends the username and the password. The server validates that the user is registered on the database, generates a token and returns it. And so it returns the token, and the token is stored here on the client. And then at some later point, when the user wants to get some data, it adds this token in the header, asks for this data, but with the header, so that it proves that the user is authenticated, and the server validates the token and returns the response. This should be 6, not 3. So we have one thing here of one process for generating the token. So here we will be generating the token by using one thing that is called GWT sign. So the method of this, we will use some package for this. We will not build everything from scratch. So this is already created, and we will simply install it with Node, and we can use this JWT. And there are some methods. One is for sign, as it's called, for generating the token, and the other one is called validate, to validate that the token is valid. So we have these two methods to see how we put in our code and in this process. And at the same time, we will use also another thing for encrypting our password. So there are two things that we will be using, the JWT and another package that is called bcrypt for storing the password safely on a database. So let's see this token JWT. Let's see. I have this thing here from the presentation. Here. The header, the payload, let me see. Debugger. Paste the token here. Okay, so this is how the token looks. this is what it's stored on our browsers. This is what it will look when it is generated and returned to the browser, to the client by the server. And in fact, this is the encoded form. If we were to decode this token, there will be three parts that are also indicated from the different colors. One part is the header that just describes which algorithm was used and what type is the token, so that the token is a GWT. Another part is the payload, which information from the user we are using to verify that this token belongs to one user. Can be the username, can be user ID, can be the user email. So this is free for us to use, what we will use for creating this token. This payload has to do something with the user. It's some kind of user identifier. And then there is a signature that it is some codification process based on a secret string that is stored on the server. So the server, to create this token, uses some secret key, and it creates this signature here. That what we cannot do is that it cannot be tampered. So it cannot be someone in the middle intercepts and change this a bit so that your user is here. This cannot happen. So I mean, even if I come and modify this part of the token, so let's say I come and I modify this part of the token somehow so that my user is written in here, the signature will do the comparison and understand that there was some change on the token. Okay, so the signature depends on the payload. And so since these two are connected, no one can modify the payload with the existing signature. And so it is an indicator that something has happened. So the signature, since it depends, it uses this base64 URL to do the codification using the header and the payload and some secret key that it's only known by the server. And so by using this process, it creates this blue part, the signature part. And that's why whenever we change something, either we change the header or the payload, not we, someone in the middle that intercepts this message and wants to change this, the signature will fail because it will not match to the original. So this is the format that we will have, and we will be storing this token to our browser, as I was saying, and then every time we do some kind of request, send it back to the client. Let me see if I can start. This is the start one. No. Check out master. And so what we will try to do, we will have some very simple form at the front. And let's say I'm putting some valid credentials. As I was saying, we're supposed that the user is already registered. So the registration we will do through the postman to create this user in the database. So I have already created the user, Anna1234 is the password. So now if I log in, I get the success message and the token. And this token is created by the server and set back. So whenever I get this token, I store it in what it's called the local storage. If you come here on the application tab and here on local storage, you will see there is this token saved, and this is the value, the same that I got back from the server. So now it's stored here, and even if I refresh, it's still here. So that means that I don't have to log in again every time to get some protected data. And let's say this is a very simple demo, but let's say that now if I request protected data, I'm able to retrieve this data. And in fact, it says exactly for which user this data is. So it also matches that it doesn't only see that there is someone logged in, but who exactly is logged in. So if you want to do also the authorization part, you can do, because you can double check which user is logged in. Because as I was saying, on the token, on the payload, there is an identification of the user. And so now I can access this protected data, but let's say I log out. If I log out and I refresh, now since I logged out, the token has been destroyed from the local storage. And so now if I try to request protected data, I get some unauthorized error. So I shouldn't be able to get inside this page anymore because I'm not logged in. Or if instead I put some other credentials, instead of 1, 2, 3, I put something that it's not, then I also get some message, bad request, because the password didn't match. So right now also the messages are not the most clear, because here it should be some kind of message to the user like password incorrect. But at least the user couldn't log in, and if tries to request protected data again, it gets that not logged in, no token was created and returned. So this we have it here. So here I'll share this. I'll share this with you. If you want to download it, resources here. So if you later want to download it and try it, there are two versions here, two branches. One is the master branch and, So one is the master branch and one is the start branch. The master branch is the finished. The start is the one that we will start now together, so that we will build this together, this demo. But so you can download it and see a bit how this is done. If you want to get some ideas, if you want to try to include some of this on your code, so you can download and clone this repo and get the code. Okay, so this is what we will try to do. And let me get back here again to the presentation. So the token, yes.
I tried to click on a link. Oh, same thing. And the link's not working. It's like 404 error when we click on it.
This one.
Yeah.
Okay, it says internal template. Could be, but it's the same. And code space. I thought it was open, but maybe. Okay. And you are logged in on GitHub and everything. Yeah. So probably then it's not open. It's not public. I thought it was. I'll create a new repo from this and pass you the new link. Create a new repo. I'll check first to see if there is some other repo that it's open for. It should create a new repo. I could create a new one. Let me do it some way. I'll just download it and I'll share the zip with you. Okay. And let me see where this is here. No, sorry, alias compress. Compress. And I'll share directly this zip. Okay. Okay, so I will start. So as I was saying, there are two branches in this when you download it, and you will see that there is the start branch and the master branch. And the master branch is with the code finished, and I will actually change to the other branch. You know how we change branches in Git? So you can use Git checkout and write the name of the other branch. And so you then move, and the files that you will see here automatically are the ones from the other branch. This is good, the branches, to create different versions of your code if you want to try something, and so you don't want to touch one version that it's finished and it's working, you can create a new branch. In order to create a new branch, so this is just for changing from one to the other once they are created. And you can also do this from here on VS Code, from the source control tab, and here check out, and it shows the different branches that they are created. So you can choose it like this if you don't want to write the command. If you want to create a new branch, let's say I would like to create Git branch Anna, and then this creates a copy of the master, whatever was on the master, it creates it on Anna, and then I could also check out Anna once it is created, and now I'm working on this branch, and I could modify something. And if I don't like it, I can either delete the whole branch or undo my changes and then go back to the master one. Or if I like it, then I should merge the two branches. This is another thing, we will see it a bit later when we will work a bit. We will have a lecture on how Git merging and pull requests work. But for now, let me go back to the master. And in fact, I will go to the start branch to start the node. Okay. So on the, let me get back here. So the token consists of three parts, the ones that we have seen, the header, the payload, and the signature. And on the payload, you can put whatever info the server wants to include. Normally, it will include the user ID, something to identify which user this token corresponds to. The client doesn't know what is in the token. It doesn't really need to decode the token or get something from there. It just sends it along with any request it does for protected resources. So whenever you do some kind of get or post and you need to get something that is protected, you send along the token. That means that you are already logged in and you can access these resources. The tokens are encoded but not encrypted. Important, it means that anyone can really take the token and analyze it and see some of this information. So it is encoded, so it's not pure text. It is these letters that we have seen, but it's not encrypted. So that doesn't mean that it's highly secure, that no one can touch it. But the thing is that the signature that we add, as I said, ensures that the token has not been changed in the process. So even if someone opened the token and saw it and could see somehow the data, it cannot be changed, or if it's changed, you will see it by the signature. Okay, so the main purpose of this is to say that the token is not really something extra secure, so not any secret stuff should be put on the payload, some account number or, I don't know, bank account or some password or something. You can put some username or some user ID, and that means that, okay, this is the token for user Anna. This is not a big deal, even if someone sees this part. And so it's not, but it's good to have in mind that it's not encrypted. So on the server side, we need to create the token, and we also need to verify these two processes. And for this, we will use a package that is called JSON Web Token. that it's here, it's how this works, this link, and we can copy the link. So here it says how to install it, npm install JSON Web Token. In fact, it is already included in this repo that I passed you. And there is these two main functions of these methods that are together with this token. One is the sign for creating the token, and the other one, so here it explains how sign works and what is the arguments that it takes. And the other one is the verify. So once you get the token from the client, to check if it works, if it is okay or no. So I will start with the code because the theory is not really, these slides are not. So let's see on the code side, let's see the README file first, so that if you want also to replicate it at home later, you can see the steps that we have to do for this. Okay, so first of all, we go to the start branch as I did, just to have the code, like if we want to build it. If you don't want to build it and you just want to check it, you don't need to go to the start, you can be on the master branch. And we need to prepare a bit of database, create a local MySQL database. So we need to go to MySQL and create database, and you can call this what you want. I called it auth and it's already created, so I will not run this again. So if I do show databases, there is this auth database that is created that I will use for this. And then add a .env file to your root folder containing the MySQL authentication information, same as we did for the full stack projects that we were creating. So we create this .env file and we pass in there the user, password, the name of the database, the one that you have created. And there is also one more thing here, this super secret, that it is this secret string that the server will use to create the tokens. Okay, so we add this also on the .env. I have already the .env here, localhost, root. The database name is auth, and the super secret, I left it as it was, but you can put any letters here. This doesn't matter, it has to be one string. The more random, the better. Okay, so it's just one string that it will be used for the encoding process. Okay, then we should run npm install. So it says run npm migrate, but first we should run npm install. The order here is not correct. So we should run npm install to install all the things that we need on the server and then also on the client. Go on the client and also run npm install to install all the dependencies. And then run npm run migrate, which, as you know, it is this file here. It calls this database file that creates the table. So the table that will be created is this one, a users table with an ID, a username, and a password. Just these three things. So on our auth database, this users table will be created with these things inside. Describe users. It has an ID, a username, and a password when we run the migrate. And then if we run npm start on both server and the client, we will see the starting page, okay, which is empty. We can do that. I mean, it's not empty, doesn't work. The login and everything doesn't work. So if I start it, and I start also the client, I get the same page as before, just that the login doesn't really do anything. Okay. I'm on the starter, right? Let's see. Yes, the user is empty, so I'm on the starter. Okay, as I was saying, we don't have any, we will not do the registration on the front, but we have to do it on the back. So even if we have to do it on Postman, let's do some registration process. So let's create some routes. Here we have the basic structure. We have our server, the app.js on our server, and it says that we will be using these routes here for anything starting with users. And it will be for the login, for the registration, and for the logout, and also for accessing any private data. This will be like the APIs that you are creating. So I'm coming to these files to create the different paths, one for login, one for registration, and one for logout. And here is the starter file, and let's create a router post register response. It's to write everything from scratch without any copying. Okay, so first route I need to create, because I need to put some users in my database. I can also insert them manually, but I want to put them in my database like this through a Postman. It's a registration route. And this registration, it's a post method, because I'm expecting that someone through the body will send a username and the password. So first of all, I'm going to grab the username and the password from the body. So the rec.body, it's an object that will include a username and password. And I'm going to grab these two so that I'll try to store them on my database. And since I'm going to be dealing with a database, I have to do this asynchronous try catch. So that I'm going to do some database query, and database query is asynchronous, so I have to add it inside the try catch, and also have to define that this is an asynchronous function. Okay, so let's say that I want to insert this is how my registration will be done. It will be inserting this user in the database. So the SQL would be insert into my users table, and users username and password, and the values that I'm going to be inserting is the one that I got from the body. So the username and the password. So I'm going to await this query. I don't even need to store anything like results, because this insert doesn't return anything in result. And if everything is correct, I can just send you have been registered correctly or something, some message. And if something goes wrong, then I'm going to put some 400 method error, but just the error message. So the error that I will be getting from my try catch, I will pass it as the error message. If you don't understand something or if I'm missing something, help me out, okay? Because I'm also trying to do this now without looking at any code, and so sometimes we may forget something. Okay, so this should be a very simple registration. It just takes a post request with a username and a password and stores it in the database. Let's try it on Postman. So my path is, I changed the port, so it's 5001 in my case, and it starts with users because remember here on the app.js, we have that this path, all these API routes start with users, and then they continue with what it is inside this users router file, which is this one. So where is this? Users router, it's actually the /route/users file. So this one. And so it should be /users/register, right? So /users/register, and I will need to pass a username and a password. We'll pass something other, so I have to use it. Sophia. Error. Okay. I have some near Sophia. I have missed something here. Quote. Closing. Let me put the code a bit. So now, okay, registered. And I have my user registered. It should be on my database. So let's see. Select all. And I have Anna and I have Sophia. One thing here, notice, okay, Anna, because I did it before with a test and it has this weird format, which we will now get to it. So the password here of Sophia, it's stored like this, like clear text. And this cannot happen. So we cannot be storing passwords like clear text on the database. So the registration is done correctly, the steps, but we have to do something with this to encrypt the password. And in fact, maybe on the very early days, I don't know if you have not seen this, but if you forgot your password, you send an email to the administrator and the administrator will tell you, this is your password, and it will simply pass you your password because you forgot it, because it was stored as clear text. This is not how it happens nowadays, and you know that when you forget your password, you simply click on forgot password and you have to create a new one because no one can retrieve your real password from a database because the passwords are stored encrypted. So for storing the password encrypted, we will use another package that is called bcrypt. Okay, and this you should install it. So we should like run npm install bcrypt, but I think it is already also included here. So it has been installed when we did the npm install at the beginning. So this package here, the bcrypt package, is the one that it's for encrypting and decrypting passwords. So this is the JSON web token is the one that will be creating the tokens, and the bcrypt is the one that will be dealing with encrypting passwords. Okay, so how this bcrypt works? First, in order to use it, we need to include it. So var bcrypt var. These are created automatically and they say var bcrypt require so this bcrypt has also two methods, one for encrypting and one for comparing passwords. So there is no method for decrypting because it cannot take one password and bring you the clear text one. But what it can do is that it can take the password, take another password, encrypt the new one, and check the two encryptions if they match. Okay, so whenever we want to check if a user logins and sends some password, since the password is encrypted on the database, what we will be doing is to compare two encrypted passwords together. We will be encrypting again the new one and comparing it. For now, in order to store it here encrypted, instead of simply putting password like this, the one that came with the body, we will create an encrypted password. And let's call it hash password, because this is the process for encrypting. It's called hash. And for this, we will be using the bcrypt packets, and we will use the .hash method of it. So the hash method takes two arguments. It takes the word, the thing that you want to encrypt. So in our case, it will be the password. And here it also takes one number, that the higher the number means the more difficult will be to decrypt the password if someone tries to hack it. So this number, it's called salt rounds, how many rounds of encryption you will do. So it's called salt rounds. And so 10 or 12, it's a pretty high number. And that means that it will create a strongly encrypted password. But that means that also it will take a bit longer. So this encryption method, it's not automatic as well. It also takes some time. So we should await it. It's asynchronous. And we should await it. And it takes the password. It takes a number that defines how many rounds of encryption we will be doing. And it produces an encrypted password. And then this encrypted password is the one that we want to store in the database. Okay, so here, instead of storing the pure text, the clean one, we store the hashed password. Yes, questions? So of course, we are not going to check all the encryption methods, details and everything, but it's good simply to know that passwords are not stored as clear text. We need to encrypt them, and we can use this package for encryption. So now let me remove the Sophia user. Delete user. Here. I miss an E. Okay. So Sophia is not here anymore, and let's create her again. Still, I'm going to post the registration. Sophia registered, and let's see now. And now I have Sophia with her encrypted password in here. Okay, so this is my registration process finished. Don't really need to do anything else. Yes.
What's the scale of the salt rounds, and like what's the normal? So you said 10 to 12 is like about average that you do?
Yes. So that's the one I have used a lot. If you use 1 or 2, it's low and it will be faster, but it will produce not as but I don't know as how many it goes. So salt rounds value. So yeah, you can check what is like the maximum. The 10 is like the normal one. We have always used 10, but I don't know if there is some maximum. Yeah, in many of the examples, you will see it with 10. This is called salt rounds. So you can check if you want, if there is like some maximum, or you can put okay. So this is salt rounds, and in fact, you could even like salt rounds. It's even better if you don't have like these hard-coded numbers in here. So you could even replace this like this. I think in the finished version that you get, it is something like this there, so that whenever you want, if you want to change it, it's easier if you have all this here, or even better if you have it like on the .env or something, or some configuration file, so that you don't have hard-coded things inside the code.
And how would we use it if it was in the end file?
So in the end file, so the same as we have these parameters, let's say that we have here some rounds 10. And so if you want to include anything from the end file, first of all, you need to import the .env. So you import .env. Let me see. I think it is imported. Remember how the here, no, not this one, this require.env. So you require the .env package that it's installed, because for this .env file to work, you need to have installed the .env package. Remember also when we were doing the scaffolding, we were saying that when you install the backend, you also need to install .env. This is for the .env files to work. And so like this require.env.config, you load this file. And then when you want to use any of the things that you have, the variables that you have installed, stored in here, you use process.env in front. So let's say that I don't have it like this, but I want to use it from the .env. So process.env, and I think I called it salt rounds. Yes, salt rounds. Like this. So you need to put in front process.env. And in fact, if you have checked a bit the database file, these helper files, you will see that this is how we were actually accessing these variables that we were stored in this env file, the host, the username, the password. So with the process.env in front, you require here this, and you access the different variables like this. Okay. So let's try the login then, so that we see a bit of a JWT, because until now we haven't seen any JWT. So instead of register, we will be doing a login, and again, we will get the username and the password from the login form, right? So on the body, it will include a username and a password. So now we, first of all, let me move this. When we have a request for login, what we want to do? First of all, we want to retrieve the user information from the database. So in this case, select will be a select all from users, where the username equals the username that we have from the form. So we go to our database table or a users table, we get the user, which name is the one that we got from the login form. And so this, we run it and we store, let's result. We store the result because this select does return this array of all the different entries that it has found that matches this username. And so we have this result, and we can first check. Let me remove some of the messages. We will create them again. So first we need to see if there is any user like this. So first we can check if result.data 0 we expect that there should be a result.data 0 if we have one user. Let's imagine that there is unique usernames, and so we should expect that if the user is found, we get as a response just one user. So we just have a data 0 from our database, and if we have this user, then that means we have found a user with this username, and we can proceed to also check if the password matches. If we have not found this user, so if in fact there is no user like this, so like this, we can respond with some error, user not found. Let me put some, I don't know what is the status message for user not found. Something. Let me check. User not found status code. 404. Okay. It's the same as resource not found. So if we don't get any user 0, that means that there is not user. Else, we can check now if the password matches. So in this result data, we will have from the database the ID, the username, and the password. And remember that the password is like that, it's encrypted. Okay, so we need to check if what we got from the body matches the one we have stored on the database. And for this, we cannot, of course, as I said, unencrypt this password. Instead, what we do, we will encrypt this one again and compare the two. And this is already included in the bcrypt. We use something that's called verify. So we will use the verify method. And we will pass in the verify method, not verify, compare. Verify is on the token. Compare, it's called in bcrypt. And when we pass in bcrypt the password that we got from the body, so this one, and the one that we got from the database. So from the database, we got the result data 0 dot password. Okay, so this is the one that came now that we want to check. This is the one that we got from the database for this user. This compare method returns a Boolean. So let's say do match. If they match, if the two passwords match, even if this is unencrypted, the compare method does it again, does it automatically. So it will encrypt the new one and it will compare the two things. So it will return if the two match. So if the two match, so if this is true, then we are now free to return a token to the user, to respond with a user. And for this, we will create our token. Okay, so let me put some comments before. So retrieve user from database. And here, if no user found, return error. And if user found their password. And so in this case, let's say if password matches, then create token. So if the two passwords then match, we create the token. And for creating the token here, we do need to use this JWT package that we need to have included. So let's import it. JWT require JSON web token. And we use one method of the token that is called sign, that it is the one that will create the token. This method needs a payload. So as I was saying, something that we will put on the payload to identify the user. So this could be the user ID, the one that we got from the database. So again, here, and this should be in a format of an object. So we pass an object with some data that we will use on the payload. So this could be the user ID. Result data is our user, remember, and ID is the ID. I can even write it like this if you like. So user ID. So I'm creating an object and I'm passing the user ID. This will be my payload. And then the other thing that the token needs to, in order to function correctly, is this secret, super secret key that I have stored here on the .env. So this super secret, because like this, it will do the encoding using these random characters. So for accessing this, again, process.env super secret. Is it like this with the underscore? Yes, super secret. Okay, and this creates our token, and then we simply send the token back to the user. So send maybe some message that your token has been created. And then also send the token. I will put some generic error here. What's this for? Status and the error. Okay, let's try it in Postman first. So you see the different steps. When the user tries to log in, sends the username and the password in the body. We go to the database and select the user that matches this username so that we get the ID, the username, and the password. If the user is found, so if it's not found, we send some error message that the user was not there. And if it's found, then we continue. So here we don't need to do an else because this will break the execution, the response status sent. And so that means that if we're here, it means that we continued. And so we check the two passwords by using the bcrypt compare method. And if the two passwords match, so then the user has entered the correct credentials and we can create a token and send back to the user. And we create the token by using this JWT sign method, where we pass some payload. This is our payload, an object with the user ID. And we use also this secret string that we have for encoding the token, for creating the signature. So if I, instead of register, I say login, and let's say I use Sophia. HTTP invalid status code. So I got some error. Use the length here, just in case. User not found. Okay. Why Sophia is not found? Where username? Select all from users. Your username equals this one. So I got user not found. Let me console log what I get from the database. And what's the headers after they are sent to the client? I think okay. If you see something that I don't see, just let me know. So let me send again and see console log here. And this is what I got. So I got Sophia. This is my console log. So I got my result data and it has just one item that then I can use the username. So it has been found. And let me remove this for now. Well, just imagine that we have the user and see if the rest will work. It finds something here. Okay, I take the opportunity, let's take a break. I'll try to fix this because now we've also been for a while here and we need a bit of break. I need a bit of water and I'll try to see where this is wrong and we come back in 10 minutes to finish this. Okay, found the error. Let me share again. Not a big deal, just a misplaced bracket. So the token was supposed to be inside the object, but I had the bracket here. So anyway, it was just here. But our process was okay, was fine. So we were getting the username and password. We were doing the login part, getting the username and password from the body, selecting the user, matching this username from the database. In fact, I stored this result data 0 so that I don't have to repeat it all the time. I stored it to a user variable and then I use this one. So if no user is found, I send back some error. If the user is found, we compare the password that we got from the user's password. And if the two passwords match, we create this token with the sign method and we send it back. Okay, so now if I was to do this login with Sophia, I get back the message, login successful, and the token that it is this token that has been created. So let's see how it works on the front end. The front end is already created here. So I created this already. I'm not sure in the code that you have. Yes, it is on the finished part as well. So let's see, does my client run? I think so. So let's see how it will go. I think I have, let me see if I'm running the client. I'm not now sure. Version of the client. And let me check. users login. Perfect, and just okay, so let's see. Okay, so yes, that's the simple form. So the backend, the frontend, it's a bit already done because the form, for example, is on the part for getting the user and handle change and handle submit, and this thing we have seen 1,000 times, so we're not doing it from scratch. There is a simple form that gets some username and login, and when you click login, it does a fetch to this login/login API, sending this information. And on the backend, same as we did with Postman, it matches the password and it responds with a token. And now my token is stored on this localhost storage. So let me show you on the front end how we store this. So this is the front end. This is my login page, and it creates, so we have a form, and with a handle change, we get the name and password from the form. We store it in this credential state, and then we create a fetch request to this user's login API. Here on these examples that you get from this repo, it uses Axios instead of fetch. I left it like this so that you have both and you can compare, because Axios is also pretty commonly used, and we can easily change it back to fetch if you prefer. But like this, you can also see how Axios works, which is another way of doing a fetch by using another package that's called Axios. But the idea is the same. It does a post request and it sends the credential, the username and password, to this API. Okay, and so from the response that we get from the fetch, remember the response is the token. So we get the token, and with local storage set item, we store the token to the local storage. So this is the only difference. We got some response with the fetch from the server. In the response, there was a token inside, and we store it in the local storage like this with set item. Okay, so now it should be stored there, and every time we want to do something, we will use it. Also quickly show you the logout. So let's say I want to log out. The logout, the only thing that it does is that it destroys this item. So if I click on the logout button, the only thing that it will do, it will call local storage.remove item token, and it will remove this item from the local storage. So this button, the only thing that it does, as you see, it just clears the local storage. You don't have to do anything. In fact, you don't even have to send anything to the server for logout. If you just remove the token, then automatically you cannot access anything. Okay, so when I click login, it stores the token, and the logout, it removes the token with these two things, the set item and the remove item. These are already methods that are already created for you, so they exist for the local storage. And like this, we have the basic login and logout done, and the front end and the back end. The only difference here that it uses Axios instead of fetch, but you can do it with a simple fetch. At the end, you only have to send the username and password on the server. Okay. So the other thing left, so this was just for registering a user. You can register, we registered this through Postman, and for logging in the user. And now the only thing left is to, let's say what happens when the user wants to grab some resource that it's protected. So the private data. So let's say we have some route that is called private or protected, or as you want to call it, request response. So before we access this private, so whenever we get a request for this private part of the page, before we respond with the data, we need to check if the user has a valid token, if the user is logged in. And for this, normally what we do is we use some middleware. So we have some middleware that will be intercepted. Remember how middleware works? It will be done before the final part. So somewhere in here, something like user logged in. So we need to create this middleware that will be doing the check. If the user is logged in, then we proceed with responding with the data that it has requested. So let's say that if the user logged in, it's okay, and we come here, then we can send back the information. So some message. Here is your super private okay, of course I can do it also in one in here, but it's used to do it in a middleware, because this user logged in, you can use it in different routes. So imagine that you don't only have this private, you have more routes, and you always have to check before doing this, is the user logged in? Is the user logged in? So then we normally place it in this middleware, or guard as it's called. And then we do the checking for that then. And then if the check is okay, we continue with the rest of the information we want from this route. So this user logged in, it's here on the middleware words. I think it's called ensured user logged in, but I'll change the name. Ensure user logged in. And so for using this from the quartz, we have to import it. Why? So it's in here, and in here in Quartz, we have this function, ensure user logged in. It's a middleware, so it takes the request and response and the next. So whenever it will finish, it will call the next, and then the next will mean that it will pass the torch to the next function in the chain of middleware, and this next function is so it's this one. So we will first do this, and then it will go in here, and it will continue, and we will get this message and the rest of the data. So imagine that here you would have to do some check on the database and grab some data only if the user is logged in. So how this ensure user logged in works? So first of all, it checks if there is an authorization header. So we said that whenever we want to access some private data, we have to send the token to the server. And the token, we send it to the server by using a header that is called authorization. So with the authorization name, we create a header. Remember when we were doing the fetch that we used the post method and options? So let me get here. So we created this options object when we were doing a post for method that we were putting some headers. Well, part of these headers now will be our token. We create a new header called authorization, and the structure is normally like this. It has the word bearer in the front, and then the token that is stored on the local storage. Okay, so this creates a request to the server that has this header, and it has bearer and the token that we have stored, and sends it to the private page that we want to access. So here, so this is the route that we want to access, the private one, and we use the fetch through Axios to get this route, and we pass in the options part, the header, the authorization header with the token. So on the other side, when we get the, sorry, it's here on the quartz. When we get a request that we need to check if the user is authorized, first we check the authorization header, if there is any authorization header on the headers. The rec.headers includes all the headers that come together with the request. The same as we have rec.body, we have rec.headers, and there we can have different types of headers. One of them is authorization. And so we check if there is the authorization header. If there isn't any authorization header, then automatically we assume that the user doesn't have any token. And so we send back an error. And if there is an authorization header, we split it. So to remove the bearer word from the front, because this is the normal way that this is structured. It's a string that has two parts like bearer and the token. And we don't really need the bearer word, we just need the token. So we split the string that comes on the authorization header, and we just keep the token. And now what we need to do is to compare the token to verify if the token is correct. And for this, we use this verify method from JWT. So verify, we pass the token, and again, it needs this super secret word that we used on the server so that it checks the signature if it is correct. Okay, so then it verifies the token that it got, and if we got here, everything is okay, the token is valid, and we just call next, which means that we give the okay that the user has a valid token and it has been verified, and we pass the torch to the next function. Okay, so let's see. I will just console log. So I modified this a bit. It's a bit different than the one that you had from the Sophia login, and then it automatically redirects her to the super private data, let's say. So that's it got the header with a token, it did the check, and then we got the here's your super private data, which is the response from the server when someone tries to access this part of the page. What happens if I'm not logged in? So I log out, there is no token. And for some reason, I know that this private, it's this link where the private data is. You see that now if I click private like that directly on the browser, if I'm not logged in, I don't get the super private data. So I cannot see it because internally the server checks and sees that there is no token, and so it doesn't respond with the data, the private data. So let me check users private, sorry. Should be like, no. Let me check the route, just one moment, because I created these routes this morning. No, it's a user. Okay, yeah, so user, not private. So the route is user. So when I'm not logged in, and even if I try to go directly to this link, which should show the private data, I get a request failed. And if I log in, either I'm redirected directly here, or even if I go to some other page and I don't know, I go back and then I copy directly the link, I will still see the private data because the token is stored, and every time I want to access this page, this user page, a request is done with the token. So what we need to remember from this last part is that, so back to our server, to our routes, when we want to access some private part, some private page, we need to ensure that the user is logged in and has a valid token. For this, we normally use a middleware that it does the check. And so this middleware, what it does is that it gets the token from the header. So now the token, every time there is a request, it should be passed on the headers. So it checks the headers to see if there is an authorization header, and from the authorization header, it gets the token by splitting it, because the header is like this, bearer and the token. And with the verify method, it verifies that the token is the correct one. And so if it's the correct, then we can send the data. And on the front end, what we need to do if we want to send the token along is to create this authorization header like this. So we create a header called authorization that has the word bearer and the token that we have stored on the local storage. Same as we were creating all the rest of the headers when we do a post method. So here as well, we create simply another header that has the token. Okay, I'm not going to spend more time with this because I want you to, I don't know, let you study a bit the code on your own, and then maybe if you have some questions, we can check them again. This is a bit of a big lecture. I think it's not meant to do in 1 hour, but anyway. And so any questions or something like this on this that, I don't know, I can explain a bit more or repeat? You can try to include it if you have some time. You can try to do some simple login, or you can leave it for later for the final project. I think for the final project, it will be nice to have some kind of user login. So even if now we don't want to deal with this, keep it in mind, study it if you find some time, how these methods work. And
could you share, Anna, the updated files that you were working on in class?
yes, there are not much different from the master, because I just changed something on the front end, because I actually like that when the login happens, you are automatically redirected to the private page. And so I used the router for this. And that's the main thing I changed on the front end, but I will share it also, because on the one that you got from the repo, you don't get any redirect. You simply have to click like, get me the, I don't know, the private data or something like this. There is a button. But I like the idea that when someone logs in, there is an action happening. Normally, also when you log in, you are redirected to your user or private page. I will share it, yes. It's not that hard, but it has to coordinate both front and back end, as always. So the back end needs to be checking some things, this encryption and password hacking and everything, hashing. And the front end has to remember to send the correct header every time. Okay. More questions?